Okay, so the next part, and I'm going to walk through kind of with the reason number 10 is not on there is that's my protein. That's like my demo protein. So I'm going to walk through what you guys are going to need to do with your own proteins. Okay, so let me start sharing my screen here. Let's see, where is... All right, so there should be a link for you guys on the lab handout. If you need me to, I can put it in the chat. But it's basically going to take you... actually, I think that it starts out, what does anyone have it nearby? It's Ag Booth. Oh, I think it's this one. Is it this one? I want to get to what it looks like when it starts.
I think it's the one that says Java.
Okay. I just wanted to get to what it looks like when it starts for you guys. This is where you should end up. Oh, here. Yeah. So you just want to make sure that you don't do the app. Okay. You want to access the free online version. So you're going to get to a page that looks like this. So if you'll bear with me for about 5-6 minutes, I just want to walk you through what you're going to need to do. And then the rest of the time you guys can kind of play with it with your own protein. So you're going to always start here from the beginning and choose the default mixture. Okay. These are also, all of these steps in these directions are in, there's like a lengthy tutorial handout that walks you step by step through. So if you need to, you can kind of pull that up, but I just kind of wanted to show a real quick overview here. You're going to click on default mixture, and there's 20 possible proteins, so that's why I had 20 different numbers. Mine is number 10. So I'm going to go like this. So there's a page in your lab handout that basically says you're supposed to put down your protein number, temperature stability, pH stability, molecular weight, and PI. Okay, so that's what we're going to get here in the beginning here. I know that this protein is stable up to 50 degrees, pH 3.5 to 11.5, so I'm going to say okay. Now, when you're going to have to tell me 3 purification strategies, and we'll talk about that in a minute. But there's these 3 columns that we have here. Each of these is going to represent a unique sequence of steps that you take to purify your protein. So you see here where it says starting mixture, the number of milligrams. That's this. That's the 511 milligrams that you start with. Okay? So that'll be what goes up top. With this little down arrow here, we're going to write the steps that we take, whatever clicks we do, so that essentially I could do the same purification that you did. So we're going to walk through that in a second just to kind of show you that. But the first thing you're going to need to do, and you'll only need to do this once, you need to figure out what the molecular weight and the PI of your protein is, because that will help you in terms of determining what you might want to do to purify. So the first thing you want to do is you're going to do a 2-dimensional page. And what comes up is that Kumasi blue. It's showing all proteins. Okay? Now the question is I need to figure out which one of those is mine. Do you guys remember? How do I stain a gel just for my protein?
An immunoblot?
An immunoblot. Okay? So when I click this, I'm going to see what my protein is. You'll do the same thing for your protein. Now I can draw a horizontal line across and it'll tell me my molecular weight. So you're estimating this. And then a vertical line up will show me the pH at which my protein stopped moving. And so that will be my PI. So that's how you'll get those 2 parameters. So now we're going to have all the information we need to kind of think about designing a purification strategy for our protein. Okay, so there's just a little question here, which is like the pre-lab. How do I know how is this information going to influence my chosen purification methods? Okay. So now what I need to do is start trying to purify my protein. And this is sort of like a choose your own adventure book. If you make the wrong choice, the alien might kill you. No, I mean, you might get fired, which is very real. If you make a choice that is wrong, you will get fired. You just start over, but just know that then that doesn't work. So the first thing we need to do here is we need to hide the blot. Okay? We can't do anything next until we hide a blot. Here is your sort of important tab for doing purification procedures. If we click on separation, we can see the 4 different kinds of columns that we talked about. There's gel filtration, there's the ion exchange, hydrophobic interaction, and then affinity. So you can pick one of those. These 2 are ones we really haven't talked about yet. These are sort of crude methods. You could do what's called an ammonium sulfate fractionation or a heat treatment. And if you click on this, for example, if you want to know what that is, you can click down here and it'll tell you what a heat treatment does. You don't have to read any of this, but as you're trying to understand, like, why would I want to choose this? Like, heat treatment allows you to increase the temperature such that some proteins unfold and then they denature and precipitate out, and maybe yours stays in solution. So this whole idea, remember when we did our plasmid mini prep, some of the stuff precipitated out so we could get rid of it. Same is sort of true here. So I know that my protein was stable to 50 degrees, so let's maybe go up to 45. I don't know, let's try 15 minutes. And I'm going to say okay. And then what happens is I get a little report as to what happened. This is where it'll tell you if you got fired if you did something you weren't supposed to. But importantly, what I would write in this first little thing here, now don't write right away, because if something doesn't work, you can't have it be part of one of these. You're only going to write 3 that are successful, and I'll tell you what it means to be successful in a minute. But I would write down heat treatment, 45 degrees, 15 minutes. I need to know what were the steps that you took, what were the clicks that you had in this program so that you could get there. Now what you're going to do is you'll say, well, what's the milligrams of protein that I have? Okay, so that's 424.4. This enrichment, this number should always be increasing because we're going to get more pure. Enrichment is like purity. Protein milligrams, that's our yield. Okay? So, and then this last little piece here, I'm going to tell you what to do here. It says impure, and then it has these parentheses here. Your purification is not done until you have 1 spot left by Kumasi staining. So I'm going to click on this and say, all right, show me my gel. Ooh, I still have a lot of spots there. I'm not done yet. Okay. Now I did help purify it a little bit, but I still have lots of spots there. All right, so I need to try something else. You know what, let's do that ion exchange. We did that today in class already, right? We did that to purify that mix of 5 proteins. Let's just do exactly what we did in class. There's the DEAE. We used a salt gradient. So those are all things you'd write down, and anytime you click on something, you need to tell me what you clicked on. We were at pH 8.1. And then we went from 0 to 500 millimolars, so that's good. And then we get what looks like this. We get an FPLC. So importantly, I need to know where my protein is. Now when we do this next week, it's going to be pretty cool because we'll see tubes, test tubes that are fluorescent green. So we'll know where our protein is. We can't do that here. So we have a magic button that says, tell me where my protein is. We do an enzyme assay. There's where my protein is. Okay. If your peaks are ever too big, you can kind of come up here and dilute them a little bit. But now I need to figure out where I want to pool fractions. And you'll notice here, remember we increased our saltiness, so there's our enzyme activity, so there's our salty curve. Here's our absorbance at 280, so here's where proteins are. So now I need to say I want to pool some fractions. Okay? And to Andrew's point, early on, you might want to err on the side of taking more than less because you're going to do another purification. So let's check this. Let's say I want to go from 60 to 80. You can press this little check and it shows you the area that you've highlighted. Well, maybe I can go like 63. Nope, 62. Maybe 61. If I want to get all that red, and I need to make this one a little bit bigger, that'll give me everything, right? So I'm going to say now, I'm going to get rid of a lot of these contaminants. So I'm going to say okay. And now it shows me, yeah, I lost a lot of protein. Look, I'm only down to 173, but because I took the entirety of that peak, I still kept 100% of my protein. And I enriched it a little bit. All right, let's go ahead and see if I'm down to, oh, I'm not down to one spot yet. Got lots of spots left, lots more work to do. All right, so I don't know, let's try one of these affinity things. Those sound fancy. Maybe let's do, maybe there's a his tag. And if I have a his tag, I need to use the imidazole. I'm going to do that. And with these, like, you're like, what is this hot mess? So you can click on info and it'll tell you a little bit about how each one sort of works. All right, I'm going to say, okay. Oh, that is magical, right? I only have one thing. This is amazing. Let's see, where is my stuff? My stuff is right there. This is awesome. I must be down to like only one. I'm going to pool everything because that is everything. So that looks like it's from what? Like 15 to 35. Yeah, I want all of that. Awesome. Oh, wait, my enrichment didn't go up. My yield didn't change. What's going on here? Let me look at a gel. All of these proteins have his tags. So I used a purification scheme that didn't make my protein different from anything else, right?
Okay.
Yeah.
I just wanted to tell you, Bailey got kicked off because of her Wi-Fi, but she's trying to come back in.
Got it. Okay.
That's why.
All right. So let's see. If I want to do something else, I always have to hide my gel. All right, darn it, that didn't work. Let's see. What if we did like an antibody? Like, oh no, let's see. Let's try something. Let's try like one of these, like the gel filtration things. I don't know. What does it tell me to do? All right, these just look like they're based on sizes. All right, I'm just gonna pick something that looks like it's middle of the road here. Oh, that was good. Separated a lot of things based on size here. All right, where's my stuff? Where's my stuff? Where's my stuff? Anti-enzyme activity. All right. Let's pool. What do we want to pool? Maybe from like 60. That looks good. Maybe from 60 to like 75. Let's see what that looks like. All right, maybe that's good. Maybe let's try that. Ooh, look at my enrichment went up. This is what you want to be looking for, your enrichment going up. Okay. I don't have a lot of protein anymore. I didn't lose too much of mine. Let's see what my spot looks like. I'm done. I have one spot. Right? That's what you want to get to. You are done when you have one spot. Okay? So I did a heat treatment. I did a DEAE column, so I did an ion exchange column. I tried a his tag, but that didn't work. And then I did a size exclusion, and that worked. So one of the things you'll have to write down here, there's a spot here that says, tell me something that wasn't successful and why you think it wasn't. Well, when I did that step that did the affinity chromatography, it didn't do anything, but that's because all of the proteins had a his tag. My stuff wasn't different from everything else that was still in solution. So I could put that down in that area for something that didn't work, and I understand why. If you get really lucky and you go through all of these and then everything worked, you're just going to have to like force it to do something that you don't want. So maybe choose a high temperature. Maybe do a pH that's outside of the range you're supposed to. You could probably try to force get fired, right? But the idea is you need to have 3 separate purification schemes that get you to here. The goal is you're going to have one that maybe has the highest enrichment and one that has the highest yield. So I want to know why you think maybe this one was the best for enrichment, why this is the best for yield. And as you're choosing these different schemes, understand that it doesn't have to be completely unique. Let's say that we know that these 3 steps worked: heat treatment, DEAE, and then the size exclusion. Just try switching the order. See if that matters. Okay, that's totally fair and valid. But I just need to have 3 that are different in some way, shape, or form. Get yourself down to 1 protein. And then there's just a couple of things to comment on here. What's your lowest yield method, your lowest enrichment method, and then 3 steps that weren't successful. Okay, so we have probably 20 minutes left here that I'd love for you guys to sort of just practice on your own, and that way I'll still be here as you're starting through this. If you have questions about, I don't know what to do here or what this means or what I'm supposed to put where, so feel free to go ahead and start. I'm going to hang out here and just kind of address questions if you have them.
Hey, Dr. Prente, do we use the default mixture? I forget.
Yes, use the default mixture. Otherwise, Hayden tried doing this this afternoon. He's like, he used the custom mixture, but I think that has 60 proteins in it. So I said, you're fine to stay with that one. I said, it's just going to be much more complicated because you've got to separate your 1 from another 59. So the default mixture is better.
Dr. Parente, mine didn't tell me it's molecular weight or it's PI. Am I doing something wrong?
So remember, that's where we need to, and let me go back to sharing my screen here. Or am I still sharing my screen? I am still sharing my screen. You guys are watching everything I'm doing. Sorry about that. All right. So the first thing, so let me go ahead and start from scratch. So the first, and you'll only need to do this once. Default mixture, I chose protein 10. So the first thing you need to do is do a 2-dimensional immunoblot, so you know where your protein is. If I draw a horizontal line across here, wherever it intersects, this y-axis is going to give me my molecular weight. That's what MR is, my molecular weight. So I'd say for this one, it's like maybe 23, and these are KD, these are kilodaltons.
Okay.
Okay, and then I draw a vertical line up and I see where it intersects, and okay, my PI, which is again the pH at which it has no net charge, so it stopped moving, I don't know, maybe 5.7, something like that. Does that make sense?
Yeah.
Dr. Prente.
Yes.
So how do you know when to really like stop purifying it? Like what should your enrichment number be around?
It's not necessarily that your enrichment number reaches a certain value. When you do a 2-dimensional gel that's stained by Kumasi blue, you get 1 spot.
Okay.
So
all I did was 1 step, and all of a sudden I have a 98.2% yield with a 33.1 enrichment.
in 1 spot?
I have 2 spots.
Ah, so you're not done yet, but you're close. You have to have down to 1 spot.
Okay.